In this video, we're going to look at one of the things that students have the most difficulty figuring out when it comes to rational expressions and equations, and that is what process to use when. The first thing I want us to look at is the difference between two terms that commonly show up, and those are simplify and solve. Simplify means that you're taking an expression and perhaps performing some sort of operation on it, but the result is going to be another expression. Usually that expression will have variables in it. There might be a time where it comes down to be a single number answer, but a lot of times you'll have maybe a binomial or a trinomial as your answer. That's different from solving. When you're solving, you're going to be dealing with an equation, and you're going to be finding the value for x. So simplifying it is taking an expression down to a simpler expression. Solving is taking it a step further and finding what x can be equal to. And as you can see here, there are four situations that come up with rational expressions where we'll be simplifying. The first one is when you have a single fraction. An example of this could be if you had the trinomial 2x squared plus 13x plus 20 divided by or over 2x squared plus 17x plus 30. In the case of a single fraction like this, the strategy that you're going to want to use is factor and cancel, meaning you will try to factor the numerator and the denominator into its lowest or simplest form, and then cancel any like terms that you have. The next situation, which requires simplifying, is adding and subtracting of fractions. An example of an adding or subtracting of fractions problem would be 5 over 6x to the fourth plus 7 over 3x squared. Notice here the addition sign signals to us that we're adding two fractions. Whenever you have an addition or subtraction problem with fractions, your rule of thumb is going to be to get and keep an LCD. LCD stands for least common denominator. So you'll be looking for a least common denominator, and once you figure out what that is, you'll try to get that common denominator in both of your fractions and keep it. You're not going to be eliminating the denominator in any way. The next process that comes up is multiplying and dividing. An example of multiplying and dividing with rational expressions would be a squared minus 4 over a squared minus 1. Notice that in itself is division, times a plus 1 over a plus 2. In a situation like this, where you have both multiplication and division, or even if we just had division, meaning that this would be division instead of multiplying, we are going to again use the process of factor and cancel. You'll be factoring each term and then canceling common terms that are on different sides of the fraction bar. Alright, the last type of situation where you would have to simplify is the situation related to a complex fraction, and I'll put my complex fraction example down here. A complex fraction is a fraction or fractions within a fraction. And so an example of a complex fraction would be something that looks like this. 2 minus 1 over x divided by 1 over x squared minus 1 over 2, or 1/2. That one looks a little bit frightening, I know, but we'll see how to deal with that in just a little bit. The general rule of thumb for dealing with complex fractions is to get an LCD, like we do for adding and subtracting, and use it to get rid of the denominators. Get an LCD and use it to eliminate the denominators. Alright, so those are the 4 situations where we would have to worry about simplifying with rational expressions. The other situation that will come up when you're working on this unit related to rational things is equations. And remember, those are the ones where you're solving. When you're solving a rational equation, you'll be working with something that looks like this. 5 over x minus 1 equals 3 over x plus 3. In this situation, you are going to be getting an LCD, and I keep wanting to say and, get an LCD, and just like with a complex fraction, you're going to use it to eliminate the denominators. Remember, the denominator is the bottom of the fraction, so you'll actually be using this process to get rid of the fact that you have a fraction, which for most people makes it a whole lot easier to deal with. Now I've included examples from Khan Academy of working out this single fraction problem, the adding and subtracting, multiplying and dividing, and this equation. And you can find those on your guidance directly after this video. There wasn't a good example for working a complex fraction, so I'd like to go ahead and do this example with you. Remember, we had 2 minus 1 over x divided by 1 over x squared minus 1/2. And the rule that I said we would use was to get an LCD and then use it to eliminate the denominators. So, in order to do that, I'll determine my LCD. That's going to be the smallest thing that each of the denominators has in common. We'll be using every factor, the least number of times it occurs in any one expression. Now remember that the whole number 2 is basically like 2 over 1. So if I look, I have 4 denominators, 1, x, x squared, and 2. That makes my lowest common denominator 2x squared. Because my factors that are different are 2 and x, x squared is basically x times x. And because it occurs twice in this expression, I have to use it twice in my LCD. Now I'm going to go ahead and multiply each part of the fraction by 2x squared. So I'll be multiplying, and when I do this, students are sometimes confused. I'm actually multiplying the top of the fraction, of each fraction, by that LCD. Multiplying on the top allows me to cancel with any common factors on the bottom. Now in this first fraction, that's not really an issue because I just had a 1 on the bottom, which I can put or remove at random. And so this part right here is just going to be 2x squared times 2, which is 4x squared. But now for my second fraction, I notice that I have an x squared on the top, which is basically x times x, and an x on the bottom. That means that I can cancel one of the x's from this x squared with this x here. And by doing that, I'm left with 1 times 2x, which is 2x. Notice that I no longer have a denominator in the top of this complex fraction. I just have 4x squared minus 2x. Now looking at the bottom, I have 2x squared times 1 over x squared. Again, I want to cancel any common factors that I can. I notice that an x squared will cancel with an x squared. 2 times 1 is 2. And then for this last fraction, I have 1 over 2 times 2x squared, and the common factor there is a 2. So I have 1 times x squared. There's still subtraction, so I'll have 2 minus x squared. Alright, at this point I want to simplify the fraction that I have left. And remember, to simplify, I factor and cancel. So I'm going to look to see if I have any common factors that I can pull out of the numerator. I notice that 4x squared and 2x both have a factor of 2 and x in common. So that means I can take a 2 and an x out of both of those. If I take a 2x out of 4x squared, that's basically dividing 4x squared by 2x. That leaves me with 2x. If I take a 2x out of 2x, that leaves me with just a 1. Remember that when you're dividing something by itself, that always equals 1. And what I like to remind students that when you're factoring a common factor, if you factor out of 2 terms, you should always have 2 terms in the parentheses. If you were to factor out of 3 terms, you should have 3 terms in the parentheses. A lot of students miss that 1 that needs to be in there. And then looking at the bottom, the 2 minus x squared, there's not really a common factor for those. The 2 minus x squared is also not any kind of special binomial. The x squared is a perfect square, but the 2 isn't, so we don't have a difference of squares or anything. So I would just have to leave that the way it is. And then I notice that there's really not any common factors that I can cancel. Remember, in simplifying, I factor and cancel, but there's nothing that these have in common that can be canceled. I can't ever cancel just part of a sum or difference or part of this with the 2 minus x squared. And so that would leave my final answer as 2x times 2x minus 1 over 2 minus x squared. So that's just a overview of some things that you would come in contact with when working with rational expressions and equations. Be sure to take a look at the Khan Academy videos, which will walk you through each of these 4 problems that I didn't do.